Enzymes are often referred to as biocatalyst. Biocatalyst means it increases the rate of reaction. Bio means they are of biological origin. What is mode of action of enzyme? Two models have been proposed regarding mode of action. One is called lock and key model. This is given by Fisher. This model gives rigidity on the shape of active site of enzyme. The active site of enzyme is so rigid that it fits a specific substrate in the same manner in which a key fits into a specific lock. Now, a specific substrate binds to the active site of enzyme, forms a complex called enzyme substrate complex. When product is formed, it is rejected from the active site. Means the shape of product and substrate are not same, because active site fits only substrate, not the product. When the product is released, enzyme becomes free. It is free to hold a new substrate. It indicates that enzymes are not used up in the reaction. The next model, which is called induced fit model, which is given by Gosselin. This model is slightly modified form of lock-in key model, because in this model, in addition to substrate and product, a intermediate is also considered, that is called transitional state. Suppose the substrate of shape is like this, the product of product is like this, and transitional state is like this. Initially, substrate fits into active site, and when substrate fits into active site, it causes change in the shape of active site to fit the transitional state, not the product. Once the product is formed, it is expelled from the active site, and it again regains its original shape, that is for fitting a substrate. That's why the model is called induced fit model. In this model, substrate induces the conformational change in the shape of active site. Next factor is factors affecting enzyme action. One factor is called substrate concentration. Effect of substrate concentration on velocity of reaction. In this graph, we can see when we increase the substrate concentration, velocity of reaction increases till ES complex is formed. The value which is called the value where it attains the maximum velocity. Then after, further increase in substrate concentration does not affect the velocity of reaction. This relationship was established by Michaelis, and he also derived a constant called Michaelis constant. Michaelis constant is the substrate concentration where velocity of the enzyme catalyzed reaction is half Vmax. Next factor which affects the activity of enzyme is temperature. With increase in temperature, velocity is also increases. A optimum point is achieved where velocity becomes Vmax, maximum velocity. Then after increase in velocity, then after increase in temperature, velocity gradually decreases, and at about 55 degrees Celsius, enzyme is denatured. Denaturation of enzyme means it has lost its tertiary configuration, and once the enzyme is denatured, it cannot renatured like DNA. But with decrease in temperature, activity of enzyme decreases, and at 0 degrees Celsius it becomes inactive. Further increase in temperature, velocity increases. Now what is the optimum temperature? The body temperature is optimum temperature. pH have same effect. With increase in pH, velocity of reaction increases. With decrease, it decreases. But endoenzyme, the enzyme which works inside the cell, works at neutral pH. But the exoenzyme which is released outside, like digestive enzyme, have different pH. Like pepsin, which is an enzyme of stomach, gives better result at acidic pH, whereas the intestinal enzyme gives better result at acidic alkaline pH. A One more factor is inhibitor. Inhibitors are the compound which inhibits the action of enzyme. It may be competitive inhibitor, non-competitive inhibitor. Competitive inhibitor resembles substrate in molecular organization, and it binds with the active site of enzyme, and temporarily a enzyme inhibitor complex is formed. But when we increase the substrate concentration, it dislodges inhibitors and binds to active site, so that enzyme substrate complex is formed. Means this is a type of reversible. This can be reversed. But unlike competitive inhibitor, example of competitive inhibitor is malonate. Malonate is a competitive inhibitor. Non-competitive inhibitor inhibition is irreversible. Cyanide is non-competitive inhibitor of cytochrome oxidase.